Welcome to part 2 of the video on the projectile motion simulation activity. So again, we're going to be going over this in class. This video is for those of you who are absent, or if you're struggling to finish your plan, you can always go in here. I'll probably have a few more tips on here than I would in the classroom. Now, the very first thing you're going to want to do when you open up your plan, and I will have the plan shared with you in Google Classroom, is you're going to want to rename it. Rename it the hour and then your names. So if you're first hour, just write first hour, or just first is fine. And then what are the first names of your group members? And if you want to have first and last names, that's fine. If you have the same first name as someone else in here, just maybe put your last initial so I know for sure who it is. So just put the names down there, and then you're going to share it with everybody in your group, and you're going to share it with me. And you might be asking, well, Mr. Rattoon, you already have access to it, or Mr. Phillips, you already have access to it. Well, we just want it shared. That way we'll get the email that it's shared, and we can quickly find it in our Google Docs. So make sure you do that. So let's look at the engineering design process. So the very first thing we're going to look at is identify the problem. So if you go back through part 1, or if you look on the front of your planner, it'll go through and it'll tell you what the problem is. And when you look at this planner, it's green, it's got different colors. Wherever you see this light blue, your team's going to have to do some work there. You're going to have to fill some stuff out. So identify the problem. So what do you think the problem is for the projectile motion simulation activity? What is the ultimate objective? What are you going to do in order to score advanced on the test? And I already mentioned it once in part 1, but if you want to score well, you have to be able to hit the targets. You have to be able to have good data so on the test day you can hit the target. And when we go back, let's see where that is. No, it's right here. Your team will then use this data to hit a target of an unspecified distance between 20 and 90 meters. So that's the ultimate goal, is that you're going to have to do that. Now, there's different things you're going to have to do in order to be able to hit that target between 20 and 90 meters. And that's going to be the whole design process. We'll get you to that step. Now, the second part of the design process is identify constraints and criteria. Well, constraints are the factors that limit the possible solutions. So when we talk about identifying the constraints, you can type your constraints in here. And there's going to be lots of different constraints for you. When you open up the simulation, it's going to look like this. When you see this part over here, and here's a blown up version of that, do not change this at all. These are all going to be the constants. You're not changing the mass, you're not changing the diameter, you're not changing the gravity, you're not changing air resistance. So on the test, these will all be required. You will be required to have these set at this exact amount. So don't be playing with all this stuff. You can actually change the cannonball, and you can, launch a piano. It's neat to play with, but it'll throw off your data. And if you're trying to all of a sudden take the test, and I say, nope, you have to use the cannonball, it has to be 17.6 kilograms, and you're complaining that you didn't test it with that, well, you were told to keep these the same. So these are all constraints. So you can list, that you have to have a cannonball, that you have to have a mass of 17.6 kilogram. You have to have a diameter of 0.18 meters. You have to have gravity sit at 9.81 meters per second squared. So make sure you keep all this the same. Now, one of the other things you're going to notice is that the constraints, what you can do, if you take this, you can actually move the platform up and down. How high can it go? How low can it go? Those are constraints. The angle, what kind of angles can you have it? How low of an angle can you have it? How high of an angle can you have it? That's a constraint. And then your speed. What's the top speed that you can have? What's the lowest speed you can have? All those would be considered constraints. Now, the criteria are the measurable requirements that a successful solution must meet. And we already talked about that. That's the same as your problem. In order to be successful, you have to be able to hit a target somewhere between 20 meters and 90 meters. However, keep in mind, you are not going to know what distance that is until the day of the test. And all 3 trials are going to be different. You're going to have 3 trials. And if you hit all 3, you're going to be scored as advanced. If you hit 2 out of 3, you're going to be scored as proficient. 1 out of 3 is going to be developing, and 0 out of 3 is going to be beginning. So the criteria is what you have to be able to do in order to successfully accomplish the task. So the next step we're going to take a look at is brainstorming. And brainstorming, this is where you're thinking through your entire project. So what are your ideas and or solutions? How are you going to solve this problem? Now you can have a beginning brainstorming idea and you can go back and you can add to this, you can modify it as you come up with different ideas. Maybe you try something and it doesn't work. Well, change it, add to it. One of the things I am going to be looking for is who in your group will be responsible for each part of the process. And one of the generic answers I often get is, oh, we're all going to be sharing in the responsibility of everything. No. I want to know specifically who is going to be doing what. Who's going to be doing the data? Who's going to be collecting the data? Maybe you're collecting data from 20 to 30 meters and someone else is collecting it from 31 to 40 meters. I want to know who's responsible for what. And that's the way you have to work as a team. Everybody has to be responsible. Everybody has to be accountable, or someone might slip through the cracks and not do anything. Again, you're picking your partners, so hopefully you picked your partners wisely. So make sure you answer this completely. Again, you're being graded on this, on how well you have this answered. The next part of the process is build a prototype. Now, this is actually somewhat done for you. A prototype is once an individual or a team chooses a promising idea to pursue, they might try out a prototype. A prototype is a model or a sample of a solution to the problem. So we've already built you a prototype. And we've already built you a basic data table. Now this data table, again, is shared in Google Classroom. So have one person in your group make a copy of it, have them rename it with their hour and their names, and make sure you share it with everybody on your team and myself. Everybody needs to have editing rights. And I'll actually go into these as you guys are working and everything's on a computer. I'm just going to go from group to group to group, and I'm going to monitor how things are going. I'll help you out if you have a question about something. I'll just get in your spreadsheet and I can see what you're talking about versus you trying to, tell me what's going on. I will be able to see what's going on. So the spreadsheet's going to look like this. However, you can modify it. You can change it. If you don't like the way this works for your team, change it. You can delete columns, you can add columns, you can duplicate columns. But this is just a basic model to get you started on collecting data. Is this everything you need? Yeah, you could use this. And I think you could do all right and you could score advanced. But your mind might think or might be thinking about it in a different way than my mind is putting this together. So if you need to modify your spreadsheet, I'm fine with that. However, keep in mind that it has to be neat and organized. I'm grading it. So if I look at it and I have no idea what it is and how it is, and if it's not done in the end, you are going to lose points for your team. You may not get an advanced or a proficient score on it. The next part of the engineering design process is to perform the test and evaluate. So now you're actually going to perform the test. And this will be done after a few days. There's nothing you need to fill in. It's just when you get to the point where you're ready to test, come let me know. If you're way behind, you may not have any class time to do any testing, or you may have to come in during lunch, or you may have to do it when the rest of the class has time to work on a reading, and you're going to have to catch up with the reading at home. So make sure you come up and make sure you get your data done as quickly as possible so you can test right away. I will set aside time in class to test, but then again, if you're behind, you've missed out on that opportunity. So keep in mind, I'm not going to let you test unless your plan is done. If your plan's not done, you're not testing. And testing should be pretty easy. You use your data sheet, you'll come up with your Chromebooks. I will tell you what distance you have to get. You look at your spreadsheet, you find out what you want to set the thing at, and we're going to do it on the big screen up in the front of the room. So you're going to tell me what to set it at. I'm going to set it on my computer. I'm going to hit launch, and we're going to see if you can make it. If things really get busy, maybe I'll have you do the settings and hit launch, and I'll just verify whether or not it's correct or not. So the test should be pretty easy. Now the last thing you can do is optimize to improve a design. is all I want you to do is when you're done with everything, just go in here and add a couple sentences. Provide a sentence or two discussing how you could improve your design. How could you make it better? And again, I'm looking for good, thought out answers to this, not, oh, we didn't see any mistakes. We don't need to change anything. You can always make things better. You can always improve things. So make sure you provide a sentence or two going through this. Otherwise, your team may lose points, and that may be the difference between a proficient score and a beginning or a developing score. Now, you are going to get 2 grades. You're going to get an assignment grade for having the plan done, and you're also going to get an assessment or a test score for can you hit the target or not. So you can go to the projectile motion. The link is provided for you. It'll look like this when you open it up. Click on the lab part of it. And a couple things in here. This right here, all that this does is when you change this settings, this mirrors that. Here, you can make it smaller and bigger. So if you launch it and it launches really far off the screen, just shrink the screen. You'll be able to see it. This is your launch. This is your, if you erase it, this stays the same. If you hit this, it's a master reset. It resets it whatever it was at the very beginning when you opened it up. Now you do have a couple tools up here. These tools are kind of neat. You have a tape measure and you have this range right here. I really like this one right here. All you do is you click on it, you drag it down, and you put wherever you see the bullseye right there, you put it right on wherever it landed, and it'll tell you how far it went. It'll tell you what the settings are. And a tape measure is just what it is. It's a tape measure. You can set it here. You can pull it out to wherever it lands. Now, ultimately on a test, this is what I'm going to be looking at. Sorry, I forgot that. I didn't have that locked down. This is what I'm looking for. So if you have to hit 50 meters, I will move this to 50 meters. Then you set your settings, you hit launch, and if you hit the target, boom, you get it as a hit. And you hit it 3 times in a row, you actually score as advanced. Now keep in mind when you try this, set at 50 meters, you can actually have it a little under and a little over, and it should still hit it. So again, if you need additional support, make sure you ask me in class. This video is designed for people who are gone or people who may need additional help on getting their plan together, because maybe you were behind with the IXL and you finally got it done. Theoretically, you could do this entire project from home and not have to do any of it in class. So if you're gone for a couple days because you're sick, maybe you just plan on doing it all. And that way you come in and it's already done. You don't have to depend on anybody else for it. So as always, make sure you ask questions. Make sure when you open things up, you save them. But most importantly, make sure you have C1, C2, C3, and C4 done from IXL. If you don't, you cannot be working on this plan. You cannot join a team until you're done. So if you're refusing to do this, well, think about it. You're not going to be able to test on it till you're done. And if you don't take a test, well, that really, there goes your grade for the quarter. So make sure you work hard on it. Again, as always, if you have any questions, just ask.